FlashForge AD5X is a lower cost 3D printer compared to the Bambu Lab P1S. But is it a better value? That's what we're going to find out in this video. Hi, I'm Ken of Wrist Innovations, and welcome to today's video to compare everything about the FlashForge AD5X and the Bambu Lab P1S 3D printers, so you can make an informed decision on which one to buy if you're considering these printers. I've organized the video into chapters listed in the description that will allow you to skip around the video depending on what's important to you. I just want to mention that I bought the Bambu Lab P1S printer with my own money. However, I want to thank FlashForge for sending me the AD5X. Okay, let's get started. Let's compare parts quality. I printed parts on both the AD5X and the P1S using PLA, PETG, TPU, and ABS, and I think you're going to be surprised at the results. I didn't print any glass-filled materials because I only had the 0.4mm hot end for the AD5X, which is not made to print those materials, which I'll get into more details later. Since this is the first time for me to use the AD5X, first I printed a preloaded design of a multicolor benchy in PLA, which turned out reasonably well. Then I began my printing comparison test for both the AD5X and the P1S printers. I printed a benchy designed by Creative Tools in PLA on both printers. The P1S benchy turned out great, as expected. The AD5X benchy also turned out pretty well. There were some defects at the bow of the benchy, but overall it looked reasonable. Next, I printed this calibration test designed by Gabox 3D on printables using PLA. For the P1S, the overhang test did successfully print all the way to 80 degrees. The various cylinder diameters measured 9.88 millimeters, 7.83 millimeters, 5.79 millimeters, and 3.78 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10 millimeters, 19.96 millimeters, 30.04 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were only a few stringers on the part. For the AD5X, the overhang test also successfully printed all the way to 80 degrees. The various cylinder diameters measured 9.66 millimeters, 7.74 millimeters, 5.84 millimeters, and 3.63 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.09 millimeters, 20.17 millimeters, and 29.98 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall also looked good, and there were little to no stringers on the AD5X part. Overall, I consider both calibration parts to be essentially the same quality and accuracy. Next, I printed a spiral vase design using PETG that was uploaded to printables by Max413049. However, the original design is by Big Bad Bison on Thingiverse.com. The P1S part turned out beautiful. I really couldn't find any defects on this part. The AD5X part also turned out well, and I couldn't find any differences in the quality of both vases. Next, I printed this truck tire out of TPU, designed by Elpcom 193290 on printables. Since TPU can be stringy, I dried a spool of TPU in my Sunlu filament dryer at 55 degrees C for 6 hours. The TPU truck tire turned out great from both the P1S and the AD5X. I didn't have any trouble using the AD5X multicolor IFS system with TPU, which is the first multi-filament system I have found to be able to handle TPU, despite the TPU being so flexible. For the P1S, Bambu Lab does not recommend using TPU in their AMS due to the flexibility of TPU. Instead, they recommend using an external spool holder. I couldn't find any real differences between the quality of the two printers' parts. TPU can be a tricky material to 3D print, but what if I told you I have a source that could print your TPU project for you? That brings me to the sponsor of today's video, PCBWay. And for the month of September, PCBWay is having a special sale on 3D printed TPU projects for up to 80% off, depending on the weight of the project. If you have a TPU project, now is the time to have it made for you by PCBWay. You can go to PCBWay's website, upload your STL file, and they can make it and ship it right to your door. They have several 3D printing capabilities, including FDM, SLA, and SLS. PCBWay can also provide PCBs and PCB assemblies, CNC machining, sheet metal fabrication, and injection molding. I have used PCBWay's service, and I can say their customer service, quality of parts, and short lead time are excellent. There is a link in the description below, and they will even provide you with a $5 welcome bonus. Thank you, PCBWay, for sponsoring today's video. Now, back to the show. Okay, now let's step up our game with a more challenging material, ABS. ABS can be a challenge because it tends to easily warp when printing because it really needs a warm environment. The standard AD5X is fully open, but you can buy an optional enclosure, which I did order. However, I haven't received it yet, so I will show you the enclosure in a future video. In the meantime, I put together this very janky setup by temporarily taping some foam board to the sides and a clear acrylic panel to the front of the AD5X. I know hot air rises, and this by no means is a legitimate enclosure, but my logic was that it might minimize some drafts within the printer just for the ABS test. By the way, I would not recommend doing this with your printer. I decided to print this vice grips tool design by 3dprintedhardware.com. I did use a brim and support because there's a lot of overhangs and some of the parts did not have much contact with the build plate. As I expected, the print from the P1S turned out beautiful. The wrench did not have any warping and it worked very well. I was pleasantly surprised that the print from the AD5X printed extremely well, especially considering it didn't have an enclosure. The wrench body had a small amount of warping, but overall, it turned out great. The wrench from the AD5X also worked very well. I'm very encouraged that once I receive the enclosure kit from the FlashForge, that I will be able to easily print ABS on the AD5X without any problems. Even though I'm not a big fan of multicolor printing due to the amount of wasted filament and how slow the prints take, since both the AD5X and the P1S have multi-filament capabilities, I had to try a multicolor print. I printed this articulated Rexagon, which is a Trex plus Dragon Flexi, by Pinky Wings on MakerWorld in 3 colors of PLA. The P1S took 6 hours to print, and the AD5X took 6 hours and 21 minutes to print. And they both created a lot of filament waste. Both prints turned out well, and all the joints easily moved. I couldn't really tell a difference in the quality of both parts. So, to summarize the parts quality section of this video, based on my experience, the FlashForge AD5X rivals the high quality of printed parts from the P1S. There may be a few slight differences in print quality, but overall, I really can't see any significant differences between the print quality of the two printers. Now, let's compare the main features of the AD5X and the Bambu Lab P1S. The AD5X has a slightly larger overall printer dimensions of 460 millimeters wide by 520 millimeters deep by 670 millimeters high versus the P1S combo dimensions of 389 millimeters wide by 420 millimeters deep by 700 millimeters high. The AD5X weighs 11 kilograms versus the P1S weighs 14 kilograms. The AD5X has a smaller print volume of 220 by 220 by 220 millimeters versus the P1S print volume of 256 by 256 by 256 millimeters. The P1S is a fully enclosed Core XY printer. However, the AD5X is an open Core XY printer, but it has an optional enclosure available for $49. They both have rigid internal frames and plastic panels. However, the AD5X has a plastic top panel and door, and the P1S has a glass top and door. The AD5X and the P1S have a maximum hot end temperature of 300 degrees C. The AD5X has a maximum build plate temperature of 110 degrees C. However, the P1S has a maximum build plate temperature of 100 degrees C, so 10 degrees lower. The AD5X has a maximum speed of 600 millimeters per second versus the P1S has a maximum speed of 500 millimeters per second. They both have the same maximum acceleration of 20,000 millimeters per second squared. They both have a filament runout sensor and a nozzle wipe feature. The P1S has a chamber fan with a carbon filter. However, the AD5X does not have either. The P1S has a multicolor filament multi-material capability when using the Bambu Lab AMS, or Automated Material System Unit. And they take advantage of the Bambu Lab RFID tags in the bamboo filament spools that will allow the AMS to recognize the color and the amount of specific materials on each spool. Each AMS unit can hold 4 spools of filament, and you can connect as many as 4 AMS units to the printer for a maximum of 16 colors. The AD5X also has a multicolor filament multi-material capability, which is called the IFS module, that is included with the AD5X. The AD5X can hold 4 spools of filament, so you have the capability to print up to 4 colors. The spools are mounted to the side of the AD5X, and they are open to the environment. The P1S has the option for a heater in the latest version of Bambu Lab's AMS system called the AMS2 Pro. Both come with a textured PEI build plate, however only the P1S has an auxiliary parts cooling fan. The P1S works with the Bambu Studio Slicer and phone app, the Handy, while the AD5X works with their FlashForge slicer as well as Orca slicer and their phone app. Both printers print wirelessly using their slicers. They both have auto bed leveling, Z-axis offset, power loss recovery, and both printers can print in land mode. Only the P1S has an internal light. You can print the following filaments on both printers: PLA, PETG, TPU, ABS, and ASA. If you install a hardened steel extruder and hot end on the P1S, you can also print carbon-filled or glass-filled materials. The AD5X offers optional 0.6mm and 0.8mm hardened steel nozzles for carbon or glass-filled materials. However, I haven't found out yet what the extruder material is made from. The AD5X has a 4.3-inch color touchscreen. However, the P1S has a 2.7 mono display to communicate with the printer. The P1S has a 720p low-resolution camera, and the standard AD5X does not have a camera. However, you can buy an optional 1080p high-resolution camera for $40, which I think FlashForge should really make standard with their AD5X. You can transfer files using a micro SD card for the P1S and a USB drive for the AD5X. Both printers have similar unboxing instructions. If you are interested in my detailed unboxing and setup of my P1S, I have a link for that video in the description below. For the AD5X, it's just as easy to set up as the P1S. Once you remove the AD5X from the box, it's just a matter of removing the various foam packaging from the printer. First, remove the power cord and the accessories bag from the foam. Next, remove the interface screen shipping bracket. Then, remove the 2 large foam pieces from the printer. Next, remove the IFS module, mounting plate, PTFE tubing, cable, 4 spool holders from the lower foam, and then remove the lower foam from the printer. Install the mounting plate with 2 screws. Attach the IFS module to the mounting plate. Install the PTFE tubing to the IFS module and to the print head. Clip the tool head cable to the PTFE tubing. Attach the IFS cable to the IFS and to the back of the printer. Install the 4 spool holders. Remove the 3 build plate screws that are holding the build plate to the printer frame. Attach the power cord and turn on the printer. Follow the screen prompts, choose your language, and connect your Wi-Fi. Download the FlashMaker app to your phone. Scan the QR code on the screen to bind the printer to your account. Next, the printer will calibrate itself by going through an auto bed leveling and vibration test. Then, load the filaments and you're ready to print your first part. Now, let's compare the cost of the 2 printers. At the making of this video, September 2025, Bambu Lab P1S without the AMS unit is currently on sale for $549, normally $699. The P1S with the AMS unit is on sale for $749, normally $949. The P1S with the new AMS2 Pro is on sale for $869, normally $1,148. The FlashForge AD5X is currently on sale for $399, normally $549. I think the best comparison is to compare the price of the P1S with the AMS at $749 to the FlashForge AD5X at $399. So the AD5X is $350 less. First, to compare apples to apples, I should add the cost of the optional camera at $49 plus the cost of the optional enclosure at $49 to the AD5X base price. So that equals a total AD5X price of $497, which is $252 less than the P1S. Let's go to my final summary and recommendations to see if spending $252 less for the FlashForge AD5X is worth it versus buying a P1S combo. Overall, I'm impressed with the quality of the prints I made on the FlashForge AD5X, including prints made from ABS even without an enclosure. And I consider the print quality to be comparable to the quality from the Bambu Lab P1S. So, you have to ask yourself if the additional $252 cost for the P1S is worth the different features of the two printers. Here's a brief summary of the features that are the same and that are different between the printers. The P1S has a larger print volume of 256mm cube versus the AD5X print volume of 220mm cube. Both printers produce high-quality 3D prints. The AD5X has a slightly higher maximum speed of 600mm per second versus the P1S maximum speed of 500mm per second. They both have the same acceleration of 20,000mm per second squared. They both have filament runout sensors, nozzle wipers, filament cutters, auto bed leveling, and Z-axis offset. The P1S has an auxiliary parts cooling fan and chamber fan with a carbon filter, but the AD5X does not have these features. They both have a hot end temperature of 300 degrees C. The AD5X has a maximum build plate temperature of 110 degrees C versus the P1S maximum build plate temperature of 100 degrees C. Both printers can print a variety of materials such as PLA, PETG, TPU, ABS, and ASA. However, the P1S, with a hardened steel upgrade, can print carbon or glass-filled polymers. The AD5X can print carbon or glass-filled polymers. However, they only offer a 0.6mm or 0.8mm hardened steel nozzle. The P1S has a low-resolution 720p camera. However, the AD5X does not ship with a camera. But FlashForge offers an optional high-resolution 1080p camera for an additional $49, which I have included in my apples-to-apples comparison. Both printers have multicolor, multi-material capability. For the P1S, the MS needs to be purchased, which I included in the price comparison. For the AD5X, the multicolor feature is included in the price. The 4.3-inch color touchscreen of the AD5X is much better than the 2.7-inch mono scroll screen of the P1S. In fact, the P1S screen is one of the biggest complaints I've seen about the P1S. The AD5X has a quick change, no tools needed nozzle swap option, while the P1S requires you to take apart the tool head, including disconnected several wires. The AD5X offers 0.25mm, 0.4mm, 0.6mm, and 0.8mm diameter nozzles, and the 0.6 and 0.8mm are hardened steel, versus the P1S offers a 0.2, 0.4, 0.6, and 0.8mm diameter nozzles, and the 0.4, 0.6, and 0.8mm options are hardened steel. Another important difference is the price. At $497 for the AD5X, including the optional camera and enclosure, it is $252 cheaper than the P1S at $749. Overall, I think the FlashForge AD5X is a worthy competitor to the Bambu Lab P1S. Just like with other Bambu Lab competitors, the AD5X has closed the gap between them and Bambu Lab. I still think Bambu Lab is at the top of the list regarding overall 3D printer hardware, software, and overall ecosystem offerings. However, printers such as the FlashForge AD5X offer an alternative for consideration, especially for somebody who has a tighter budget. What do you think? Which of these two printers would you buy? Let me know in the comments below. If you'd like to see my video titled Elegoo Centauri Carbon Printer, Better Value Than Bambu Lab P1S, that link is here. If you'd like to see my video titled GD-Q2 Combo, a worthy competitor, that link is here. Thanks for watching. Bye!